As director of the Climate Change Institute at the University of Maine, Professor Paul Mayewski is actively engaged in research and public education about the changes now underway in polar and high altitude regions around the globe. With the enthusiasm of a born explorer, let me tell you, he translates scientific findings into compelling explanations that have great appeal to wide audiences. We're talking films, books, and beyond. This morning, he'll explore what science is now telling us about the Arctic climate, which he regards as Earth's first responder in a warming world. Welcome, Professor Mayewski.
Thank you, David, and thank you to the Camden Conference and the Tech Wizards, and thank you to the audience for attending. It's my second opportunity to speak close to President Grimson and to follow his very wise perspective. And my presentation, I hope, will be not only supportive, but it will also help us to, It will also help us to understand a bit more about what science can actually offer. My presentation touches on several points: consensus related to the science, surprises related to the science, gaps in knowledge related to Arctic climate, and then how mitigation and adaptation should be, at least in my opinion, viewed in the context of future climate. Obviously, when we look at the polar regions, Antarctica, a continent 1.5 times the size of the United States, on average 3,000 meters of ice, is a very different situation from what we find in the Arctic. The Arctic is an ocean surrounded by land, and the sea ice that covers the Arctic Ocean is 1 to only several meters thick. And if we take a look at the seasonal behavior of this remarkable event on Earth, we see tremendous change in the location of and extent of sea ice throughout the year. This tremendous change in the whiteness of the planet is really the key to what we're talking about here. When the planet is, or portions of the planet are white, they reflect up to 100% of the incoming radiation. And when the sea ice, in the case of the Arctic, is removed, it presents a dark ocean surface. That dark ocean surface absorbs radiation, and even more importantly, it also gives off heat that would otherwise be trapped. It's called polar amplification. That means that for 1 degree of warming, you can have at least the net effect of 2 degrees centigrade of warming in the local area. Of course, all of this is largely dependent on what we've done to the planet in only very recent decades. CO2 has increased by 1.5 times, and perhaps even more importantly, the rise in CO2 is 100 times faster than anything that we've been able to measure in the 800,000 years of record that we have available from ice cores. There are certainly plenty of reports that talk about climate change, that talk about the Arctic. I'll focus just briefly on the IPCC. I'll mention other things about them in a moment. Under the United Nations, reports come out every 2 to 5 years, but the biggest reports every 5 years. They represent 195 governments, and the consensus report, undauntingly, is that greenhouse gas rise is a consequence of human activity. Within various IPCC reports, there's tremendous depth in terms of what's happening to the Arctic. On an annual basis, reports such as the Arctic Report Card come out, which give us up-to-date understanding of a variety of things: changes in sea ice extent, impacts of warming. The next 3 slides give you a very quick summary of what the impacts of warming are in various mediums. Obviously, there's been significant loss of annual ice, but also tremendous loss of multi-year sea ice, which is actually one of the pinning points that starts off the freezing of sea ice. Acidification of the ocean, changes in ocean thermal structure, and as IPCC always does, they basically give you the effect, positive, mixed, negative, and a confidence, and we can see that in general, food provisioning, fishing, polar bears, walrus, crabs, bowhead whales, etc., are all negatively impacted. And remember that the ocean is one of our largest food sources. one of our most important resources on the planet. We are, in fact, a water planet, and we're beginning to see an absolutely new ocean appear. Impacts of warming for frozen ground are dramatic, very intense. Lake ice is appearing during the year for shorter and shorter periods. So seasonal snow ice is changing in abundance. River discharge is increasing. Obviously, plants and animals are migrating and changing in their behavior as a consequence. And then, of course, tremendous amount of infrastructure damage. The reddish parts of the diagram show you the damages incurred on an annual basis in millions of US dollars under the high emission rates, and then the blue under the medium emission rates. Roads, buildings, airports, railroads, pipelines, all dramatically impacted. So what do we have in order to understand how the climate will behave in the future? And this is clearly very important. We understand the clear and present danger of what's going on today. The top plot shows you the prediction, IPCC prediction for world temperatures by 2100, 2 to 4 degrees centigrade rise, dependent primarily on whether or not greenhouse gases continue to rise, whether they level off. You get that range. We take a look at the Arctic average, and this is the critical thing to look at. The average is about 2 times the world average. However, while the trajectory of these two projections for future climate are absolutely sound, we're going in this direction without a doubt towards warming, we need significantly more temporal and spatial detail, because obviously we don't live in a mean world or an average world, we live in more localized areas. So how well do the models do? The models do a phenomenal job of giving us a basic understanding of the direction that we're going. But if we look at these two plots, exactly the same time period, this is a time period that has already passed. The upper left is the instrumental record. Notice the very red areas, implying that the Arctic is the fastest warming region on the planet. And if you look in the lower right, this is the climate model. It gives you the same basic trend, but it doesn't show you the anomalies on a regional basis. This is critically important as we begin to plan for the future. Now, again, I'm not saying that these models are unimportant. They're consensus models, they're critically important, and they give us the trajectory, but we need to know more. Between 2007 and 2012, compared to roughly the previous 20 years, the Eastern Arctic increased in temperature by 5 degrees centigrade on an annual basis. That's the equivalent of doubling the length of the summer season, which is quite remarkable. Think about doubling the length of the summer season in the place that you live right now. This is why there has been so much tremendous disruption to the people and the ecosystems. Now, to give you an even, I think, more shocking realization of what this means, this 5 degrees centigrade rise in that 5-year period is equivalent in magnitude and speed to the massive, abrupt change in climate that occurred about 11,500 years ago at the transition between the last vestiges of the Ice Age and modern climate. Now, that is, to me, a very sobering phenomena. And if, in fact, we take a look at where that increase in temperature for the Eastern Arctic, which was 5 degrees centigrade, remember, between 2007 and 2012, it's a good 4 degrees centigrade higher than even the Arctic average temperature. So there's a lot to be learned from this regional detail. Could we have predicted this abrupt climate change? Well, we certainly know diagrams that we and the European in the early 1990s, we discovered abrupt climate change. We knew that it existed. And we're looking for ways to, in the past, understand whether they're not a precursor. The fact that it happened in the modern era is because of this dramatic rise in CO2 and the speed of this rise. If we'd looked at the sea ice record now with hindcasting, we, in fact, would have seen it coming. And that's, I think, a very important thing for us to think about in the future. Can we see these events, sea ice extent change, and many others, and can we predict them for the future? As President Grimson mentioned, once you warm the Arctic, you change the thermal balance between the polar regions and the mid-latitudes. This changes the pattern of the jet stream. The jet stream divides cold air from warm air, and it has hemispheric influences. It brings cold air into places much farther south, warm air north. It increases storms because the surface area connection between cold and warm increases. And of course, it creates droughts, floods, fires, as President Grimson mentioned. We have had, since about 2015, an increase in frequency in the middle of winter, the middle of darkness at the North Pole of temperatures because of the fact that the jet stream allowed warm air to get all the way into the North Pole. And the net result was the North Pole has been on occasion in midwinter above freezing. This is today's temperature situation, absolutely today. The northern regions to the north of Greenland are 20 degrees centigrade than the 1979 to 2000 norm. And regions where we live right now, where I'm speaking from, are 18 degrees centigrade colder than that norm. This is created as a consequence of that tremendous, irregular, and unstable behavior of the jet stream caused by Arctic warming. But there are other things that are going on that we need to think about making predictions for the future. The Mount Pinatubo volcanic eruption, 1991, ended up in a 1 to 2 year cooling. And if you take a look at the record for that period, it actually was a -4 degrees centigrade cooling in the Arctic. That would, in a warming world, have a tremendous impact on, for example, transportation, shipping in the Arctic. Granted, a brief period. If we take a look at the effect of melting glaciers, in particular Greenland, which is the greatest contributor of any ice sheet, as President Grimson mentioned, to sea level rise, we see that fresh water, in addition to the salty water that makes its way basically from west to east across the North Atlantic, that fresh water addition changes the density of that water. It lessens the likelihood that it sinks. The less it sinks, the less it draws warm air from North America up to Europe, have the potential for other anomalies, the potential in a warming world for the northern Scandinavian regions to be actually colder than they would normally be in a warming world. And then, of course, we have the elephant in the room, permafrost melting. And as permafrost melts, it releases methane. Methane is 30 to 50 times more effective in capturing heat than CO2 is. And we look at this projection for the time period 2090 to 2100 from the IPCC model, when the Arctic is expected to be +5 to +6 degrees centigrade warmer than it is right now. This could happen much earlier, and it could happen abruptly. And we would have another, obviously, major transition. So to summarize quickly, human activity is dramatically altering the physical and the chemical climate. I say chemical because not that the Arctic is necessarily a very big emitter of toxic substances, but all of the ice in the Arctic is a sponge for the toxic substances that are being emitted throughout the Northern Hemisphere and the globe for that matter, but particularly the Northern Hemisphere. And as all of this ice melts, it introduces toxic substances into the local water, into the ocean, and the indigenous people of the Arctic who tend to eat marine mammals, these marine mammals are, when they absorb toxic substances that stay in their systems, and as a consequence, indigenous people have increasing rates of cancer because of the fact that melting ice is introducing chemicals. At the same time, of course, there'll be vector-borne diseases migrating farther north, and all of the things that we know go along with warming. The Arctic climate is extremely sensitive to even small changes in climate. We just got an example of that from 2007 to 2012. We also have in the past the Norse colonies, which existed in Greenland from 1000 to about 1400 and disappeared within a matter of just a few years because the shipping routes that resupplied them from Europe stopped as a consequence of cooling barely 1 degree centigrade that allowed sea ice to be more extensive and trap those colonies. Arctic climate change has far-reaching effects. President Grimson says this. I hope that you believe the examples that I've shown you. And the bottom line is that a warming world leads to an unstable climate. And climate instability is even more so pushed as a consequence of very sensitive changes in the Arctic. Climate change can operate faster than a political cycle. Abrupt climate change tells us this. That's quite remarkable when you think about it. Political cycles are on the order of 2 to 5 years. Abrupt climate change, dramatic changes in climate can operate that fast. So if we want to, for now and in the future, have the most responsive mitigation and adaptation strategies, we need to think about these multiple scenarios for the future of climate and environmental change in the Arctic and, for that matter, all over the world. We need to think about occasional cool periods. We need to think about the elephant in the room. Thank you.
All right, so for this question and answer session, again, I need your questions. If you'll send them in, mention your hometown. We'll bring back President Grimson, and who is the head of the Arctic Council, and Professor Mayewski is going to stick with us here. We've had a number of questions, Professor Mayewski, but then we'll get to President Grimson too. It gets at the paradox of the Arctic, where there's economic opportunity, shipping lanes and resources, and the fact that that also makes what you've just been talking about, Professor, worse, because increased economic activity, if it is not clean activity, gives us more climate gases. The question is, how do we reconcile the open, as the ice melts, new shipping lanes versus that itself creates more of a problem?
It's an excellent question. And of course, whenever, in this case, a new ocean opens up and new land masses open up, there's the fight for more resources. I think that's the significance of the Arctic Circle, of the Camden Conference, of including science in all of these discussions. Clearly, there will be resource depletion in the coming decades in the Arctic, but it's extremely critical for us to understand what we've done already, to understand the value of renewable energy and how, in a world, in particular in North America, where we have an infrastructure that in fact is quite old. It was phenomenal in the 50s to the 80s. But now when we have to think about how we're going to rebuild our infrastructure, we need to think about more renewable energy. So one can hope that we will continue to make good policies, that we will continue to be smart about what we do, and that we begin to think much more about renewable energy than extraction. There are certain things that obviously will still be extracted, but we need good policies to make sure we do it in smart ways. We all want these things. It's not going to stop our desire for them, but we need to be smarter than we've been in the past.
By the way, I failed to give credit where it was due. That last question was from Tillman Crane of Camden, Maine. Thank you very much for that. There were some similar questions as well. President Grimson, just do you want to follow up on that? We touched on that when you talked about, hey, we're not going to close down production of LNG gases from the Arctic before talking about how about coal in West Virginia and so forth. But what about this idea that the Arctic itself could produce more of the problem that's destroying the ice?
Well, I don't think the Arctic is contributing to the problem so far. You can't really argue that from any point of view, whether a scientific point of view or a business point of view. And just to give you a concrete example, the big oil company of France, Total, decided to withdraw from all explorations in the Arctic. So as we have to concentrate on what's happening here and now, the problem is not in the Arctic. The problem is in the United States, in China, in Asia, in Europe, and elsewhere. And it's very important that we acknowledge that. In fact, you can see in parts of the Arctic a remarkable example of how renewable energy can indeed happen very quickly. I often draw the attention of people to this triangle in the North Atlantic, from Greenland to Iceland to the Faroe Islands to Scotland and to Norway. In the early years of my life, all these countries were primarily fossil fuel countries, imported oil and coal. They are now, each of them in their own way, a shining example of renewable energy transformation. Iceland has over 100% clean energy, Norway close to that. Over 60% of the electricity production in Greenland is also from renewable energy. Faroe Islands will, within a few years, be 100% renewable energy, and Scotland, in fact, has achieved remarkable progress in wind energy, for example, in recent years. So whereas you had before almost entirely fossil fuel-based economies in this northern part of the North Atlantic Arctic map, in what I often call the Middle Arctic, you now have a primary example of a renewable energy success. And it's one of the reasons why Norway, Iceland are among the most prosperous countries in the world. So you can also go into the Arctic and get concrete examples of renewable energy transformation in a remarkable short time. So people who argue that it's not possible for the rest of the world to go towards renewable energy should make an Arctic visit, not to study oil drilling or anything of that sort, but the renewable transformation in the Arctic.
A follow-up question comes from Edanur Hardal of Elazig, Turkey, from Turkey. And I'll start with Professor Mayewski on this, but it picks up on what President Grimson was just talking about. Next 10 years, if we're going to address this issue of decreasing climate gases, is there anything, Professor Mayewski, that leads you to think that we can really take a bite out of this problem over the next decade? I mean, Bill Gates, Microsoft fame, just published a new book about breakthroughs we already have, breakthroughs that we need. But what's your sense of this? It's really almost a question, Professor, about why you continue toiling in this space. What would give you hope that we could make some progress?
That's a very important question. Certainly, President Grimson has already partially answered that, and I'll answer on behalf of what I hope will happen in Maine. Maine has tremendous potential for offshore wind power. It will be a great employer for the people of Maine. It will be a great resource. It's the equivalent of several nuclear power plants, and this sort of renewable energy is popping up all over the United States. In addition to the Middle Arctic region, it's beginning to take over. It's a matter, of course, of how we give tax incentives for this renewable energy and how we create new jobs. And the Biden administration has been very smart about making the point that there will be many new jobs created from renewable energy.
Well, let me, if I may, add on that, because in recent years, clean energy, solar, wind, geothermal, have become so cost-effective that they don't need any subsidies. They are, in fact, a much better business than the old fossil fuel to the model. Many people ask how is it that Iceland has become 100% clean energy? It was not because we were climate visionaries. It was simply because it was good business for us to move away from oil and coal. One of the reasons why Norway and Iceland and Scotland, all these three countries 100 years ago were among the poorest in Europe. That's why you had so many immigrants in the United States from Scotland, from Norway, and from Iceland, because people fled the poverty that existed in these countries. Now they are among the most affluent in the world. So I think it's very important that people realize in the United States that if the US wants to be a winner in the business competition of the 21st century, it is imperative that you move quickly into renewable energy. Look at China. 10 years ago, I had a long debate with my good friend Al Gore about China and climate, and he was blaming China was a hopeless case. Now, China is the global leader in solar energy, wind energy, electric cars, geothermal urban heating. And if the US doesn't get it act together, China will corner the global market for the technologies in these areas. So it is a strong business case for the United States to use the next few years and definitely this decade to make sure that the US is a global leader in the renewable energy transformation.
Thank you, President Grimson. Professor Mayewski, I mean, you mentioned offshore, and this gets to a query that we have about almost, we think about, well, did the Chinese do enough to fix their climate issue? But what about ourselves? When you talk about offshore, people don't like the fact that windmills can block the view. And then we got an interesting related question from Aidan Saulnier from the University of Maine at Farmington. Do you think that the transportation of green energy through ocean cables could be successful in the U.S.? But then he also mentions the power company in Central Maine Power Company, running into trouble routing the power to and from Quebec. In other words, we don't want the infrastructure of distributing green energy in our backyards either. This may require some quick rethinking on the part of how we regard our own neighborhoods.
Certainly. In the case of offshore wind for Maine, it's actually quite offshore. And I believe that there is a hold on having it very close right now that the governor has put into action. And clearly the stakeholders, in particular fishermen, mariners, need to be brought into the equation. I also believe that in terms of potential ecosystem disruption, if a tiny percentage of the funds that are dedicated to building this offshore infrastructure are also dedicated to thinking about where it'll go, how it will impact the ecosystem, it's a smart way for us to proceed. Getting this power onshore in the case of offshore wind is the very same thing that's, of course, Norway has managed or is in the process of doing for the UK and Europe. It's doable. It's being done. It's being done many times. There's some sensitivity, but at the same time, it's important to realize that our oceans are changing. And for example, lobster fishing may very well change dramatically. The lobstermen need new jobs if this happens. They're extremely experienced in the marine environment, and new positions will open up. This is all, we're talking about a transition over the next several years, over the next couple of decades. And if we're smart and consider how to work this out in an equitable way, it certainly points the path. And just to follow up on President Grimson's comment about not needing subsidies, it's true. I agree. However, to make the transition from our current infrastructure in the United States to the next one requires a change in policy and maybe even some additional stimulus at the same time.
All right, Professor Mayewski, President Grimson, thank you so much for this discussion, and thank you for being willing to come back tomorrow for part of our grand discussion.